Hello, everybody. Welcome to San Antonio. I've been with InterSystems for about 8 years, and I look after parts of our analytics platform. So what I'll be talking you through today is what that open analytics platform really means to an organization, and kind of showing you what it means to different people who are doing analytics tasks and implementing analytics stuff. What this stuff is what we're going to talk about. I assume most of you have been to the keynotes this morning. The freedom of choice thing and the speed of innovation, those are really key things that we're going to see in action right here, right now. Okay, so first I'll do a little bit of a lengthy, or I hope a lengthy demo of what it means a day at work at the San Antonio credit card company. I'll probably be tripping over my tongue at least 3 times with that. Then I'll tell you a little more what an open analytics platform is, what that means for InterSystems, or what we offer there, and then we'll dig into the things that I showed in the demo. I'll talk through those, what those really mean, how those all came to be, and then we'll wrap up. And if we have time, we can play buzzword bingo. So, a day at work with the SACCC. This is Eric. Eric is a data engineer. Eric works at the San Antonio credit card company, and his role is making sure that the right data ends up in the right place at the right time. So that's what he does on a daily basis. So what he does today is he'll be getting the transaction logs, the credit card transactions for September that have all been annotated with whether they were fraudulent transactions or not, based on kind of those call things, those robocall things, as which Joe Lichtenberg showed you in the Joe and Jeff session earlier on. So that's what Eric does, and Eric is very hands-on. He likes to work with the console. He likes to use tools like just a simple bash, like Notepad, all sorts of utilities. As long as it's hardcore and it's got a dark background, that's what Eric likes to use to get data from A to B. Second person in our little story is Sophia. Sophia is a data scientist. Sophia works at SACCC as a data scientist specialized in kind of building predictive models for predicting fraud. So we already saw a very interesting demo of that earlier in the Joe and Jeff session. So now we'll dig through this in just a little more detail, and that's what she does. She has a couple of favorite tools that she likes to work with. And she works based on the data that she gets from Eric. So, third person working in the broader analytics department at SACCC is Amer. Amer is sort of let's say, the chief compliance officer. What he does is making sure that everybody's looking at the very same. So many people want to do analysis, and there's many people who are sort of empowered or entitled to look at those transaction logs. But if you just hand out an Excel file to each and everybody, you'll come to a meeting and everybody will have different results and different interpretations of things. So it's Amer's job to make sure that people are looking at a common model, a model that represents the business, that represents what people want to see, and he'll just make that available for others to query. And then finally, our fourth character here is Bob. Bob is the manager of the group. Of the overall department, and his job is just to spend money. So what he wants to do is to make sure that he can find out where fraud is happening, and based on that, make sure that he can allocate the budget appropriately so that we can prevent fraud going forward. So he likes to work with Excel because that's the tool he knows how to handle, and he'll just want to explore that data and then decide for himself. So you can see that Amer is probably very concerned about how his boss works. So with that little introduction of our 4 characters, let's turn to a demo. And this is a live demo, so well, you know what that means. I'll first have to switch to this so that I can show you what our friend Eric likes to work with. So Eric is wrong wrong directory. This is also really an Eric thing. So we have our transactions from September. So we can look at that if we want, if Notepad supports it. So simple CSV file with transactions, credit card transactions that are of different. There's a couple of different types. Well, anyhow, that's not really something that Eric cares too much about. He just wants it to be loaded into the database as soon as possible. So let's try and do that. So for loading the data into the database, we're going to use the bulk loader utility that ships with InterSystems IRIS. So it's a Java tool. So I'll start with Java. I've already set up my class path, so that there's a little less room for making small typos. So the simple mover is kind of our bulk loader utility. And what we do with that, oh, I'm too quick. Crap. So what I need to do to instruct our utility, and that's really to Eric's liking, is set up a properties file that describes where I load my data from and where it goes into. So we've got a simple CSV file that we start from. It has a header, so I don't need to spell out what our columns are going to be like. You give it the target URL, target username, password, and then the name of the table that I want to create. I'm going to create a sharded table in this case because, well, if you want to see a sharded table, come to my session at 5. So I just typed exactly what I was just doing. Data transfer the simple mover. Eric can type much faster than I can. The properties file is demo.properties. And then it just does it. It creates the table and it starts loading the table. And you can see that that goes pretty quickly. So it's, there's about 500,000 records in that data set, and it takes in total about a little under 20 seconds to get that into the database. Of course, Eric is Eric, and Eric wouldn't be satisfied any faster. So let's try and make that file once more, and we'll use another mode which is available through with some restrictions on the target tables. That's called XEP, that some of you might be familiar with. And we'll be making sure that this can be automatically inferred and that you don't have to do anything, and that will just choose that for you. But now, watch closely. I'm going to press start, and then you have to really watch it because it's going to pass by before you. Okay, so much for demo cleanup. So what I really meant to do was into a new table, and this is going to be pretty quick. So it creates a table. And 2 seconds later, my data is in the data set. My data is in the database. 500,000 records in a simple table. So Eric's happy. First part of the job is done. So second character in our little story was Sophia. Sophia was a data scientist, so she likes to work with tools like Spark, Python, and she's going to use a Zeppelin user interface to work with that. Jeff already talked through Zeppelin a little bit in their last keynote session just before lunch. So I'll just talk you through what our friend Sophia does. So Sophia starts by taking a quick look at the data. So first, in Zeppelin, in notebooks like this is called a notebook application. It's somewhere between a full IDE and a command line interface, so you can type code and then see the results in a sort of fancy fashion. Works really well to document your code. And Zeppelin is an open source one that works well with Spark, so that's why we're using it. So first, she takes a quick look at the data, so you can see that if you look at the raw transactions, you can see what sort of data is in there, and you can see how it's laid out a little bit. You can do some little graphing, but we weren't here to do SQL. We wanted to do things with Spark. So here, I'm going to use the IRIS Spark connector to load our transactions table. do a little bit of grouping by. So this is very familiar to people who are used with SQL, but now really in a sort of a method paradigm. So you've got a dataset object, and you just apply methods to it. So you want to sort your method, you want to sort your object, your dataset. You want to aggregate your object. And as you can see, there's only very few fraudulent transactions, which actually is good news, of course. So let's take a closer look at what else we can find out. So if we can group by the different types, we'll see that actually our fraudulent transactions only appear in transfer and cash out style transactions. So the other ones aren't interested. So probably the type of transaction is an interesting parameter to predict fraud. So maybe we don't even have to look at the other transaction types. So let's look for a couple more clues. In order to look for clues efficiently, or Sophia writes a very simple utility function that prints the fraud rate for a given data set. So I just pass it my dataset object and apply my function to it. So the overall fraud incidence is 0.12%. So that's very low. So let's try and find out if there's particular other predictive elements that have like an impact on this fraud rate. This is just exploring before we unleash the machine learning libraries at it. So, for example, fraudulent transactions might be the ones that kind of empty an entire account. So if somebody takes control of or hacks your password, they will want to get all of your cash from your account. So let's try and find out if there's transfers or cash out where the source balance is zero after the process. And there you can see that indeed the fraud incidence rate is already about 5 times higher than it was in the overall data set. So that's probably also an interesting thing to keep in mind. And this one, which takes a little longer, is going to be even more interesting. So let's try and take a look and see if the incidence of fraud evolves during the day. There's a column in the data set that captures the step information. Step is sort of a 1 hour increment versus the first day of the month, midnight. So if I do a simple modulo as an additional column, so again, simple method by which I change my data set, I can just do a loop and see what our fraud incidence is. And you can see that there's a massive difference between the different times of the day. So that at 3 a.m., 4 a.m., 5 a.m., that's really when the crooks are awake and are fiddling with our money. So we can just confirm that in a nice graphic that will show us. So this is the overall evolution of number of transactions during the day. So as you can see, people wake up, start paying, and then they by 10 p.m. they're done paying and they go back to sleep. But if you look at the crooks, they wake up during the night, and that's really when there's a spike in fraud. So this is very interesting for Sophia. So she's definitely going to include the hour of the day as in her model building exercise. So there we go. So now this is obviously a little more dense piece of code. So what we'll be doing is we'll be taking our starting data frame. So we're starting with all our transactions, and we're adding the hour of day column. We're adding 2 more columns with the eventual error between the balance information. We're going to split our data set into a training set and a test set, because every well-behaved data scientist does that to make sure that if you validate your model, that you validate it with data that wasn't used to build it in the first place. So in order not to overfit your model, we're going to tell Spark what our predicted field is and what sort of input fields he can use. And then we're going to build a random forest model, which is actually a bunch of big if-then-else statements. So we combine those in a pipeline, fit that, and at the bottom here you'll see a of how this tree model actually looks like. So it's a big if-then-else statement, and so here most nodes obviously predict 0, so because the incidence of fraud is very low. But here there's a couple of nodes in your tree that, that flag as fraudulent. So let's validate our model. So we're now going to look at the predictions for our test data set, and Sophia will be happy because model accuracy is actually pretty good to start with. So 99.94% accurate. But that's a little misleading because if you look at the actual predictions per category, well, if you would have the trivial model that says it's always good, you would also have a very similar accuracy, because remember that the incidence of fraud is just less than 0.2%. So anyhow, this is not terrific, but it's good enough for our experiments and definitely for a demo like mine. So let's try and save all our predictions. So again, we're really in this object mode, so we're looking at data sets as an object, adding a new column to capture the probability that something was fraud, and we're eventually going to write that into a new table in our database so that Amer can have a go with it in the next section. By the way, tomorrow, I think at 2 p.m., Amer will be presenting a session dedicated to Spark where he'll go into a lot more detail about what's happening here behind the scenes. So that's good. We're going to have our output data, so our predictions are going to be in our database. But we shouldn't forget something really important, our model. We want to be able to use our model in order to send a text message to Joe telling him that, hey, somebody tried using your account for something that might be fishy. So we also need the model to be in IRIS. And saving the model to IRIS thanks to the IRIS connector is as simple as just saying pipeline model, ISC save, demo model, and we're just saving it as a class on the IRIS side. So I'm going to do that. And if things work fine, I can show a simple, silly web viewer that tells me what my model's doing. This is horrible, but it's just a demo interface. But you can see that if I start filling in time information, so if I have enough data for my model to work, then you'll see the probabilities, you'll see the information flowing here. And you can see that the probability evolves somewhere between 0 and 1. So this is according to these inputs, the model tells me that it's not fraud. That was Sophia's work. So building a predictive model, delivering the model and the predictions to her colleagues. Now we're on to our third character, which is Amer. So Amer's job was to make sure that everybody could be looking at the same thing, that we're not just delivering an Excel file and then hoping that by sheer luck, people will be looking at the data in a consistent way. So what Amer will be doing is creating a new cube class, so creating a deep sea cube, so an InterSystems IRIS BI cube that has dimensions according to how we want to structure things. But rather than lose a lot of time, I'm going to use a little tweak here. And and I'm going to generate a base cube. Not good. Cube with given name already exists. That's very well possible. So that's why we have a... no, this is it. This is it. There we go. So this is going to be a very, sort of a simple wizard utility which we can, which we might have a UI for. Actually, there is a much more exciting, let me zoom out a little bit. There's a much more exciting demo that you can find on GitHub that is called Analyze This, which starts from a CSV file. So actually skipping all of the work that we did earlier on, and that just automatically builds your deep sea cube, builds these sample dimensions, and builds a sample dashboard even. So very nice demo that's available from GitHub. So we've got our so we're now in the process of defining our business model, where I have set measures. So I want to always look at average amounts. I want to always look at the hour of day in just from midnight till 11 p.m. And for example, other things that you might want to capture in such a dimension is a hierarchy, such as what is considered to be a nighttime transaction and what is considered to be a daytime transaction. So if you just give an Excel file to everybody, some people will start their day at 6 a.m. and others will start their day at 8 a.m. So making sure that you can express all of that consistently in a model is a very powerful thing. Here in the listing, I can add a reference to our PMML model, but in order to save time, I'm going to import, or at least hope that my ready-made one is still there. So that's going to be in here. Okay, that's going to be better. Ah, it's gone. It's not gone. Where am I looking at? Ah, it just has that name. Well, there we go. So, I cleaned up a couple of things here. The most important things are that I used pretty names for everything. I normalized the measures a little bit. So this is now a cube that we can start building, and then we have a uniform, super fast, multi-dimensional analysis environment that people can use for their exploratory efforts. Okay, so now that we have that, we can look at it in Analyzer in Deep C, and we can build a simple KPI already. But well, Bob just knows Excel, so Bob will be using this from another interface. So Bob was our fourth in our little story at the San Antonio credit card company. So Bob is using PowerBI. PowerBI is sort of, well, Excel on steroids, and a very nice data visualization tool, very easy to work with, very nice self-service capabilities. But it obviously, it would by default start loading data into memory. So if we're talking about 500K transactions, that starts adding up. So we may not want to do that right here. So let's see if Bob can use the work that Amer did. So Bob will go fetch data, and this is the most recent and most prototypish part of the demo. So please pardon me clicking outside of the box every now and then. So we're going to look at my local hosts where I have a database. Nope, almost wrong. Where I have an InterSystems IRIS instance with an analytics namespace. And what am I going to do here? I'm going to look at the catalog, and I can look at the tables. That is something that, if you remember Vish's presentation in the keynote, so Northwell Health is already using Power BI on top of IRIS, but they're using the built-in ODBC connector that works with any ODBC data source. We want to add to that. We want to give people a little more, and not just allow them to work with tables, but also allow them to look at the cubes. So here are the cubes that I was working with. So I'm going to look at this one, and here I can see the nice dimensions with the pretty names, and I can see my fact table, and I can import that whole lot in one go. And now our good friend Bob can start building his interface based on the data that is sort of normalized and structured along the sort of business agreed corporate model that Amer put in place. So after a little bit of loading, I'll talk a little more about where we want to go. This is really a first draft that was in a different shape yesterday evening, by which I mean it's really very, very recent. And yeah, we'll get to that in a second. So what this did is this loaded our data model. It should have imported all of the, there you go, all of the relationship between our dimensions. That's also sort of metadata that we already have stored in our Deep Sea repository, in our BI cube definition. So we serve that up to PowerBI so that PowerBI can leverage that when building applications. The only little tweak I have to do is that it forgot that the hour of day is actually a number. So, and now Bob probably had somebody do this for him, and now Bob is really ready to get going with this, and he wants to start with like a big mention of how many records we had, how many fraudulent transactions we have. So we're gonna, I pulled over the count, and then I want to make sure that that is limited to only the cases where we have fraud. I want to show that as a number, and I can of course rename this. And you can do many more things. So I can also create a little graph that shows again all of the ones that are fraudulent. And now see, in order to know whether he should spend his budget on giving our friend Sophia a pay rise, he wants to check out how the predictions compare to fraud and fine. Well, this is, I haven't yet selected fraud. So anyhow, so here you can see that, well, we didn't get everything right. So these are what we're seeing, the two bars added together are all of the fraudulent transactions, and actually we only flagged a small number of them. And then it's sort of, how are you going to tune your model to be more harsh and make sure that you flag as many potential cases of fraud as possible, but thereby annoy your customers quite a bit because they'll have regular transactions that are being refused? Or will you focus on making sure that the ones that you block right away are going to be true positives, are going to be real fraudulent cases, and you can follow up on the other ones that eventually turn out to be fraudulent in sort of a post and after the fact session. So there's all kinds of other fancy things that you can do here if you want to throw in some more dimensions. So that's PowerBI. So this is what Bob does, and then at the end of a long day, he'll just decide what he's going to do with the money. So that was our little introduction to 4 people working at a credit card company. There's more people working there. So we haven't, in the demo, we didn't go down into the role of the integration developer. So, for example, Wes here is the person who will then take the model that was developed by Sophia and put it into the workflow, sure that it's being invoked when a credit card transaction is being processed. So that's the sort of workflow development that you saw in Jeff's presentation earlier today. We also haven't talked about Mary. So imagine that you get this text message that says fraudulent transaction captured. You want to yell at somebody, or you want to somebody. We would possibly send them a survey, and we get a number of records back, and there will be information in there, and you can't necessarily read through all of that information, and you might want to use some natural language processing to try and identify trends, etc. So those are all. So now we've seen 6 totally different people who are doing totally different tasks, but they're all analytics. How can you deal with that with a single platform? So there's a lot of different disciplines in the broader area of can't do all of them. So that's one. That's looking at the people. If you look at technologies, so people are using different technologies and different languages. So your platform needs to be able to cope with that. And we've only been looking at the San Antonio credit card company, but if we would have been looking at MasterCard or Atos Worldline that are dealing with a much larger data set, you don't want to necessarily complicate the work of the people doing the actual work. So that's why it's interesting to consider an open analytics platform. One, just try and solve everything by itself and do a mediocre job at it, but really tries to offer solid services that specialize, or solid capabilities that are specialized, and just partner with others when there's particular things that the other ones do best. So InterSystems IRIS isn't going to be delivering machine learning models, but we want to make sure that we work well with Spark, that we work well with Python, etc. We want to make sure that we speak multiple languages, that we can interoperate with these other tools. So make sure that interoperability is a key part of the platform. And if your platform can scale transparently, you're just making it more efficient for your people to concentrate on the work that they like to do, rather than have to worry about, well, but can my tool deal with that size of data? So if the platform can abstract that away, that's very powerful. So that sort of brings us to our design philosophy that was also already described earlier on today in the keynotes. So an open platform that's interoperable, that works with multiple solutions. A platform that remains intuitive regardless of which language you're used to, that is transparently scalable and of course reliable. So that kind of brings us to our open analytics platform. So in our platform, we've got at the center of it a couple of embedded technologies, third-party tools. So as said before, we're adding support for Tableau, PowerBI, and Click, and support for relevant industry standards that then other tools could leverage to access the data. So let's take a little bit of a closer look at what our friends did. So how did InterSystems? Eric first got the FTP, the data set through FTP. We could have automated that, but I wanted to leave that out of this conversation. He could have managed the SQL database through the command prompt or through an interface. That's all fine. But for loading the data set, he used the bulk loader to get the data as fast as possible into our data set. So that's sort of a nice interplay abstracted by that command line tool. So we've got our database that supports scaling up and out. If you want to learn more about the scalability pieces, come see my other session at 5. The JDBC driver has a couple of very nice enhancements that we've been putting in InterSystems IRIS to just massively increase throughput. And there's more coming up in 2019-1. And then this bulk loader utility leverages JDBC to get the data into the database as fast as possible. So how did we help Sophia? We helped Sophia by making sure that she could use and that we would guarantee that Spark has the most efficient way of leveraging data that's stored in InterSystems IRIS. We helped Sophia by making sure that she could just drop her generated model into InterSystems, and on InterSystems IRIS it could be leveraged in for batch execution or for embedding into a workflow, as was demonstrated in the keynote presentation. So, the Spark connector, so what would that mean? We were looking at a sort of single instance scenario, but if you kind of scale out to multiple nodes, and you would just use the built-in JDBC connector that comes with Spark, you would have only one Spark process talking to one data node on the IRIS side, whereas our Spark connector obviously knows how your IRIS architecture looks like and will be able to kind of open parallel connections to each of those and make sure that you utilize all of the processing power on the Spark side and all of the processing power on the IRIS side together. Again, more information about the Spark connector in tomorrow's session by Amer, titled From Spark to Finish. So how did we help Amer? So we helped Amer by allowing him to define BI cubes in a consistent way that express business logic and business information like this. How do you roll up your hierarchies? What are the important measures here? In a way that is still accessible for others in the organization. Things that we didn't cover in this demo is setting up a schedule by which these are automatically refreshed, or building a dashboard with KPIs that you can easily embed into your applications. In a little more detail, So InterSystems IRIS BI, formerly known as DeepC, is an OLAP engine. So it has very high performance OLAP cubes that are built on our bitmap index technology. And they are universally accessible. You can query them using MDX if you're a smart BI tool, or you can access them with SQL if you're any tool. So that's making this a very good vehicle to kind of standardize your data models for querying and transparently benefit from the fast bitmap indices. Embeddable OLAP querying capabilities. So there's an analyzer tool, hoc analysis. There's this dashboarding solution that's really meant to allow you to work with for embedding the data, embedding your analytics results. If you're looking at providing more of a self-service experience, that's when we're looking at Bob again. So Bob was able to access the cube that we defined on the IRIS side from PowerBI. So PowerBI is one of 3 connectors that we're in the process of building that gives a great user experience, has a lot of flexibility in building fancy dashboards, and is able to access our data set. So we're building this for Tableau, PowerBI, and ClickSense, and the priorities here are making sure that we end up properly in the. That's a bit of a no-brainer, of course, but it's also making sure that we have ownership of it. That if you would be using the vanilla ODBC connector that ships with any of these tools, and there's a problem, that people with problems can come to us and we can help them straight on, so that we're not dependent on these guys to fix any problems they would have with their ODBC connectors. So first-class citizen, making sure that they use direct querying. If you remember when I was opening PowerBI, it was importing the data. That's because the prototype doesn't have number 2 yet. So it by default, tools like PowerBI and Click will import the data into memory and then do all of the querying there. Couple tens of thousands of records. But if you go to look at cubes with millions of records, and we've got customers that have it that way, that's not what you would like to do. And of course, that wouldn't be using the IRIS performance. And then the third thing is that user experience, making sure that people can immediately get all of the metadata out of the cube definition when they're working with these tools, so that they don't have to define their dimension structure all anew. And then the last thing I just want to briefly pitch, because this is a sort of an idea that we're developing, and this is something for which I'm really interested in hearing your feedback and hearing your ideas, because we're still speccing this out. But so now, what we've now looked at is a little workflow that consisted of a number of different tasks that were executed by different people using different tools. We did this on the 1st of November. There will be another data set with all of the data from October. So we'd have to go through all of those steps again. We have to involve those 4 persons' activities all again to kind of reproduce the analytical artifact, to reproduce our dashboards, to reproduce our updated model. So what we're looking into is how we can build on our experience with interoperability and make sure that we can automate this, that we can make this more reproducible. So that's an idea we're developing. This isn't going to be part of 19.1, but if you have ideas or if you have situations in your analytics practice where you're thinking, yeah, this is something that we also have trouble with, please let me know. I'm really interested in hearing your requirements and taking them into account. That was more or less what I wanted to talk about. So summarizing, InterSystems IRIS is an open analytics platform. We want to give you the flexibility of choice. We have a couple of embedded technologies that are really fast for OLAP querying, so the BI cubes that we looked at, natural language processing. More about that in a session at 4 p.m. Our partner, Aluna Group, will be presenting what they did with that NLP technology. But next to those embedded ones, we also have support for third-party tools with these dedicated connectors, Apache Spark, ClickSense, PowerBI, Tableau, and we can build more. If we have a critical customers asking for something, we're happy to look into it, and we're constantly scanning the market ourselves, of course. And then finally, We provide integration for a number of very important standards in the analytics environment, such as PMML for kind of porting models from your analytics environment into your production environment without having to recode everything, and UIMA for unstructured information management. So that's what we do. That's what we offer with that. Any questions?
So the current connection to BI is basically putting the data over to the Tableau or whatever BI product is, kind of accessing the data directly. But there's a plan to do that.
Yes, absolutely. So our connector prototype already works that way. The PowerBI one is just something that we couldn't in the course of last week.
Does that mean that we kind of eliminate that middleware altogether? Maybe Tableau requires a separate instance of that data residing on their server?
Yes, for Tableau wouldn't be deploying in a server mode like that. PowerBI wouldn't be deploying in a server mode. Tableau has something like that. And Click also has something like that, but essentially you can look at them, or the way how we want to support them is really as being pure clients that can talk straight to InterSystems IRIS. Thanks, good question. Very good question. So whether they're going to be backwards compatible to connect to Cache. There will be a session about adopting InterSystems IRIS, I think in 10 minutes or so, or how much over time am I? And 15 minutes. And Andreas will be talking more about what compatibility we're foreseeing. To the extent that that's something that's going to apply here, I believe that probably they're going to be transparently compatible with Cache 2015.2 and up. We'll first build them for Iris, make sure that they work fine, that they work fast, and that they give you the user experience that we want to give you, and then we'll check if they also work for Cache. The current JDBC driver in 2018.2, but again, Andreas is going to confirm that during his session. I think the sort of intended compatibility matrix is that our Iris drivers will support connecting to Cache instances starting with either 2018.2 or 2019.1. Any other questions? Then thanks. Take a look at the app for more sessions about analytics and for the survey. And we'll be posting recordings of this on learning.intersystems.com. Thank you.